Welcome back to the OptiCore tutorial video series. It is finally time to show a complete rendering setup with Blender. In this video, I will be using the Cycles render engine, and I will focus also for this video on the basic setup and the most important features to get you started with the setup. Discussion of various options as well as performance impacts on different setup choices will be left for a separate video, and also in a later video I will show the setup with the LuxCore render engine as opposed to Cycles to give you some further variation. So I hope this video will be helpful to you, and if you're only looking for specific aspects of the setup, then make sure as usual to check out the section markers in the description below. So let's get started. We are starting from a fresh empty scene in Blender. First, I will just select the Cycles engine and then load a lens design from a Zemax file. Here I will use the double Gauss lens that I have shown in part 2 of this series. As a recap, this lens has 4 groups: a singlet at the front, followed by a cemented doublet, another cemented doublet, and finally another singlet. The cemented doublet is important for this tutorial because of the interior cemented face. The aperture is located between the two doublets. I now remove the cross-section view and increase the mesh resolution to something usable. I also add ray fans of the 3D rings type with a large number of rays. For this lens, this is efficient and so the most accurate option. Adding field of view angles of 10 and 20 degrees and activating RMS focus, which will make each ray fan end at its best focus position individually. I will also stop down this lens to 50%. The ray fans are hidden for later use. Now the glass material setup. For the first lens, we add a new material and just call it Glass 1. In Cycles, the options for the material are Glass BSDF or the slightly simpler Refraction BSDF, which I will use here. The roughness is set to 0, and the question now is what to set as the refractive index. If you download the latest OptiCore, I have added a helpful output in the console. It shows the refractive index for each surface of the lens. In this case, there are 10 surfaces simply numbered from the right to left in this view. Surfaces 1 and 2 for the first lens, 3 to 5 for the second lens, and so forth. Lens 1 is a singlet, so both surfaces get the same index, and we need to create only this one material, Glass 1. For lens 2 with the internal surface, this is different. Here you can see 3 different values, where one is close to 1. This is because for the internal surface we need to set the ratio of the refractive indices before and after the surface. For the second doublet you can see the same thing, and finally there is a singlet at the end. Now, copy each value from the console and place it into the Cycles material. Besides the glass, we are also going to add a blackout material that will be assigned to the lens edges, apertures, and so forth. For this tutorial, I don't want to deal with internal reflections or other stray light to keep it simple. Here, I select a different diffuse BSDF with color 0. Now I tap into edit mode, select the edge faces and assign the black material. I will also set the viewport color to black for visual confirmation. Lens 1 is now set up, so we repeat the same process for lens 2. The first part of this doublet actually has the same glass as lens 1, so I simply reuse the Glass 1 material. Then 2 more materials have to be added in this case. Glass 2 for the rear surface and an interface material. Selecting the correct faces for assignment may be tricky in this case, so as a trick I first assign the interface material to everything and then select the outer faces separately and assign their materials because I found this the easiest. You might know better selection tricks than I do. Finally, the black material is again added to the edge. This assignment can be double checked, as you see here. While still in edit mode, let's quickly talk about the interface and refractive index ratios. Here I activate the face normals to be displayed. For the first and last surface, these always point outside, while for the internal face they point forward, or in this view to the right, just as I draw in here. In the second doublet, this is exactly the same. The refractive index that you set is always the index inside the face divided by that outside the face. And the lines shown by Blender point outside. If you use a rendering engine where refractive index of smaller than 1 is an issue, you can try flipping the surface normals for the interior surface and use the inverse refractive index ratio instead. And once again, I will repeat the material definition for lenses 3 and 4, which also share one material, so that lens 4 is simply assigned glass 4. With the lenses completed, the aperture also is assigned the black material. Now we move to the sensor/camera setup. I will unhide the on-axis ray fan and zoom to its focus position. Selecting a vertex, I place the viewport cursor there. You might think that you can simply put a normal camera of perspective type at this location, but this will not give you the results you want. Instead, I will show you two options for the setup. For option 1, move the camera towards the lens and let it face backwards. Make the camera of orthographic type and increase its scale. Now I enable the other ray fans as well and create a cube at the focus position and move it so that the front face is at the focus location. This cube represents the sensor. The size is increased to cover both off-axis ray fans. The orthographic scale of the camera is matched to the size of the cube, and just for this tutorial, I make the image area square. The sensor is assigned a diffuse material. Roughness could slightly alter the result, but it is a very minor effect and I wouldn't bother about it unless you are doing something extremely specific. Likewise, color shouldn't affect the rendering performance and is at your own discretion. In order for the setup to work, we also need a stray light housing. For this tutorial, I will just do something super basic in order not to take too long. I create a cube and scale it to cover everything. I move it so that the front face just overlaps the first lens. The back should be behind the sensor. I then separate the front face and perform a Boolean operation with the first lens to create a hole. We now have a plate with a hole and an open box. Both are assigned the black material. We are now almost ready to render, only an object to render is needed. I will demonstrate this with an HDRI background scene. For performance reason, I just use a 4K texture, which is rather low. Higher resolution will be part of a separate performance related video. I also deactivate interpolation here and set intensity to 100, which I already know is a good value for this setup. I limit the render region to the camera view and turn on viewport render. Please excuse a little jump in the recording here. I had to re-record the segment because by default Cycles uses the CPU so hard that the screen capture turned out to be affected. So I limited the threads and had to re-record this part. You can see something happens, but we don't get a clear image with this setup yet. This is because for Cycles we need to make one particular change to the default settings, and that is the filter glossy parameter, which needs to be set to 0 to deactivate it. Now if we turn on the render again, you can immediately see an image of the scene forming. One additional render setting that I should briefly mention here is the number of bounces of the light paths. For this lens design, Cycles' default values are large enough. If you render a more complex lens system, make sure to increase the number of transmission and correspondingly total bounces. A lens forms an image upside down, so we rotate the camera by 180 degrees to bring it upright. And also, because the camera is now looking backwards, we actually have to invert the X scale to flip the image horizontally. To show you that is correct, I create a normal perspective camera in front of the lenses as a reference and just let that look into the scene. You can see now, switching between these two cameras, that the image now looks the same. Just as a note, with the default perspective camera and default focal length settings for that, and also the default field of view size, it just happens that the field of view between the perspective camera as reference and our complete rendered lens is about the same. So this is just coincident for this example that I picked and doesn't mean anything. Now option 2 of the camera setup. This one works without the sensor, so it is hidden just as well as the sensor camera. I only put the viewport cursor back into the location of the sensor. Now I again create an orthographic camera with the same size as the sensor camera, but facing forward. I will displace it backward by 1 unit. Now I activate the depth of field option with the focus option at the same 1 unit as the displacement. Let's check the viewport render. The image is again rotated by 180 degrees, but no x-axis inversion is needed in this case because the camera is facing forward. You can see the image forms and it looks similar, but the edges look a bit more vignetted. Furthermore, there seems to be an artifact in the image corner where the mountain glitches a little into the sky. This is because for this setup, the f-stop value must be sufficiently low, otherwise this kind of setup will not render correctly. What low enough actually means is not something that I can say in general because it will depend on the lens design you are working with. Just as a demo, if I set it to f10 here, it looks really wrong. We even have a double ring, and this is in fact an artifact because the minimal straylight housing that I created is not good enough for this lens. I left it in here because it's a nice example why modeling an appropriate housing can be important, even though I don't want to go into too big detail here for time concerns. In the first setup with the diffuse sensor, this effect is also present, but it's just not as obvious. I will briefly demonstrate a simple fix here by duplicating the front cover, move it to the last lens, and scale it down a little to match the last surface and size. Now in render view, the double ring is gone. And finally, for this specific setup, an f-stop of 1 seems to be a good choice to get a correct rendering result. Alright, this concludes the basic setup with the Cycles render engine, and you have seen how rendering through a simulated lens system can work. Please let me know in the comments below if this was helpful to you or if you would like to see something else in particular. As I already mentioned at the start of this video, further videos will follow where I will show the same setup using the OptiCore render engine and also to discuss further aspects of setup options and performance aspects. So until then, thank you for watching this video and see you next time.